this is Miss Litton, and this is a lovely Friday afternoon filled with excellent APBio students. Say hi. Hi. Ready to review Chapter 5, Membrane Structure and Function. So the first thing I want to skip to is our understanding. When we look at a cell membrane, the components of the cell membrane, component number 1, I would say is a what? Exactly. I would say that about a phospholipid. And what makes it work is it's amphipathic, which means what? It has two different regions, one that is hydrophobic and one is hydrophilic. Did you get your hair cut?
What, me?
Yeah.
Long time ago.
Oh, it still looks super cute in a non-creepy teacher way. So it's amphipathic, okay? It's different on either side. So what that sets up, when you have a cell membrane, you put the hydrophobic parts in the middle, okay? And those are your fatty acid chains, yes? And then the phosphates are on either end, and those are hydro. That works because it's either to the interior of the cell. What do you call the liquid portion of the cell? What was that? I'm sorry, you're mumbling. Cytosol, right? And the cytoplasm is just the whole entire area between the nuclear envelope and the cell membrane. The liquid part is called the cytosol. Perfect. Okay? Or it's the outer medium that the cell is sitting in, that liquid. Okay? So we have those phospholipids. The thing is, they're kind of loosey-goosey because what kind of fatty acid chains are they? Unsaturated, which means they have what in their chain? Yeah, what did you call it? One of you called it a funny name. Jinky. Right. Oh, kinky. Oh, I thought she said jinky. I thought that was a good word. So what's going to fill in the gaps for us to keep the continuity of the phospholipid bilayer? Cholesterol. Excellent. And that works because cholesterol is underneath the umbrella of being a what? A lipid. And these are phospholipids, so lipids with lipids. That makes sense. Yes? Now, intersperse what you would call the yes, of that fluid mosaic model. The mosaic is created by what? Proteins. Proteins have a lot of functions in a cell membrane. Do you agree with that? Could we please review the protein functions in a cell membrane? They could be what? Channels, carriers, cell recognition, receptors, enzymatic, and junctions. Good. Those sound like really important things, right? So part of those have things to do with letting things come in and out of our cell, right? Channels and carriers. And by the way, even if you were a what? You could have something bind like into your receptor, which then triggers a gate to open to allow something to come in. Okay? All right, so we went over the proteins, the cholesterol. Okay, do we want to go inside or outside now? Inside. Okay, that's what you said, inside. What's just to the interior, all is kind of supporting the cell membrane? Cytoskeleton, acting, kind of moving back and forth. What's to the outside? ECM, extracellular matrix. But what are the components of that extracellular matrix? Could be proteins, it could be the glycocalyx. We break down the glycocalyx to two categories. What are the two categories? Glycolipids and glycoproteins, right? Glycolipids are a carbohydrate side chain attached to a lipid, and glycoproteins are a carbohydrate side chain attached to a protein. Okay? When we think about glycolipids and glycoproteins, this could have to do with what? It could have to do with receptors, right? And so they play a critical role in how a cell maintains homeostasis. Okay? I think we did that. I think we feel good about that. Okay, so I'm going to go ahead and jump to passage. Are you good? Am I moving too fast? You all right? Yeah. Okay, so when we think about how things can get across the cell membrane, then we could say it would go what? Through the phospholipid bilayer, but not if it is large or charged. Okay, not because it's large, because it can't what? fit through, and not, it can't be charged because of what? The hydrophobic region. It would repel it, okay? So through the phospholipid bilayer, but not if it's large or charged. Or it could use a channel or a carrier. Are those specific? Yes, very specific. Okay, if you're a channel, there's one thing you move. If you're a carrier, there might be two things you move in specific locations. So what's a carrier you can think of that does that? Sodium, potassium pump. That particular carrier requires, because you're going against the concentration gradient. Okay? Channels or carriers, or what's another way we could do it? Endo or exocytosis, whole membrane. Okay? So let's break that down. Movement across that cell membrane, all right? So what are our three different ways we could do that? Through the phospholipid bilayer. Now, when you talk about phospholipid bilayer, then we can deal with the whole thing if you're large or charged, yes? But really what you're talking quite a lot about, I mean, you know that you could have O2 diffuse, you could have CO2 diffuse, you already know that. What's another thing you could have diffuse? O2, CO2. What is that? H2O. Now, once we start talking about H2O, what are we talking about? Do you see how this ties in? Okay. Then we want to talk about things like this, right? So let's describe. What would this side be over here? What would it be? Hypertonic. And this side would be hypotonic. Which side has the most osmotic potential? Okay, so this one has high os potential, whereas this one has what? High osmotic pressure. We all right with this? So we're tying this in when we say through the phospholipid bilayer. Things like O2 and CO2, they will diffuse. That's just going from a higher concentration to a lower concentration. Water will diffuse, but when water diffuses across a semi-permeable membrane, then you're specifically talking about osmosis. We all right? Now, I've got hyper and hypo. What am I missing here? Yes, isotonic. Okay? Now, when you say it's isotonic, are the fluids separated by the membrane like frozen? What are they doing? They're moving, but there's no net change. No net change. However many molecules are moving from side to A to B are moving from B to A. When you say something's hypertonic, which way is our water flowing? If this is side A and this is side B, which way is our water flowing? A to B. Water must flow from the hypo. Perfect. Okay? Water must flow from the hypo. Now, let's use an example. I want to continue. Where are my glasses? I'm still continuing. Oh, okay. Sure, I will continue. Okay, sorry. I'm going to come back to this page because it's a nice little summary. Okay? I'm going to have a dinner party tonight. I'm going to have a dinner party tonight, and I like to make this really good sriracha ranch dressing. It's basically ranch dressing that I make by hand, and then I put in sriracha in there, so it's a little, okay? And I want to have firm, crispy carrots. I do not want to have wilty carrots. What do I need to put my carrots in to assure that my carrots are firm and crispy for my dinner party? Just plain water, or should I put some salt in there?
0.9%.
What would make my carrots the crispiest, the firmest? my carrots in? Yeah, distilled water. I put it in double distilled water. Okay? Do you know why I would put them in double distilled water? The water around them would be what? Hypotonic. The carrots would be hypertonic. Water must flow from the hypo. They're going to flow into my carrot sticks, swell up the vacuoles, which push against the cell walls, which makes my carrot crunchy. Right? If I put them in salt water, what would happen? Water would flow out. Okay? Now, don't be weird. Patience. All right. Good. This right here, okay, that's a pickle. Do you know what a pickle was before it was a pickle? It was a cucumber. What? What must have happened to the cucumber to make it a pickle? What are the two kinds of pickles you can have? Dill or sweet? Think it out. How do they make dill or sweet pickles? Put them in what? Salt, vinegar to get a dill with seasoning dill, or put them in sugar to make them sweet. And then what happened? What happened to your cucumber is it became a pickle. Does that make sense to you? Okay? In the East, not here, they salt the roads. Now, let's go back to Unit 1. Why would you salt the roads? To do what? Not traction. It makes the ice melt. But it also kills the plants. Why would it kill the plants along the edge of the road? The water around the plants is salty water. It'll make those plants what? Hypertonic. The water around the plants hypertonic. The plants themselves would be hypotonic. Water must flow from the hypo. Got that? Okay. Now let's apply it to another situation, which is like a lab question or one of your essay questions that I gave you. I had a lab assistant make up all the solutions for your lab, but they forgot to label them. Okay? So I don't know which solution is which. Do you have an idea of something I could do to figure out which solution is which? Because right now I have all these bottles of mystery solution, and I don't know which one is 0.2, 0.4, yeah. Okay, got it. They really did, didn't they? I have, okay. I have a lot of bottles. They're laughing because they thought it looked like an elephant. Okay, now, I have these bottles. I don't know which one is which. Do you have an experiment I could do to find out which solution is which? Could it involve dialysis tubing by chance? What could I do? Oh, I've got to put the dialysis tubing. Dialysis tubing, just write that. And rubric. I still haven't done that. Okay, what could I do with dialysis tubing and my mystery solutions? How? That's not going to be very good. Think of your experiment that I've asked you to read and that you're setting up and doing on Monday. Right? I could take some dialysis tubing and I could fill with it with mystery solution X, some other one with Y, and another one Z, and another one W, right? I have all these mystery solutions. I could weigh them, right? I could then take all these mystery solutions that I have and I could put them together and I could put them in some distilled water. What would you predict? Osmosis will occur. Diffusion of water across a semi-permeable membrane. if all of these solutions, if I have a 0.2, a 0.2, a 0.4, a 0.6, and a 0.8, I don't know which one of these, X, Y, Z, W is what? Oh, application level. Is it possible that if I put a 0.8 molar solution inside of a baggie versus a 0.2 molar solution in a baggie, which one is more hypertonic? 0.8 molar, because it's more concentrated sugar, yes? So which bag, if I let it sit in water for 30 minutes, would gain the most weight? Because water must flow from the hypo into the hypertonic bag. Are you with me here? So if I did change in mass, percent change in mass, and I weighed them before and after, and I kept it constant, same amount of dialysis tubing, same amount of string, same amount of solution I put in there. But I weigh them, put them in for 30 minutes, take them out, and weigh them again. As long as I left room for water to move in there, for the bag to expand, then I would expect the 0.8 should have the highest percent change in mass, and then conversely, then 0.2 would be the lowest percent change in mass, yes? And then just line these up. Highest percent change of mass must have had the highest molarity, the most water moved into it. Why? Because 0.8 molar had the most osmotic pressure to come in, yeah? Whereas 0.2 would have had the lowest osmotic pressure. And maybe for a control, I could throw in what? Just distilled water, right? Because if I took that data and then I graphed it, right, and I had 0 molar, 2 molar, 4, 6, 8 molar. So I would expect, and if this were percent change in mass, I would expect the 0.8 to change the most, right? And I would expect it to go like this, and I would make a best made line with a ruler. So good. Across them, I would expect that, wouldn't I? So then if I brought to you something, you know, if I another mystery solution, I weighed it, you could go, oh, it came in right here. Oh, then that must be a 0.5 molar solution. Do you see how I could use that to figure out anything? That would be my scale that I set up. That's what you're doing on Monday. Okay? You're going to get 3 dialysis tubings. You're going to open them up, tie off the ends, put in the assigned molarities for your group, tie off the end again, cut off the strings, rinse them off, roll, squeeze, squeeze, mass. Right? Do you know what I'm talking about? And then you're going to let it sit in the water. You're going to write the time down. I would write it, you know, on a piece of paper. Time in for this molarity. Time out when it's 30 minutes. Pull it out. Roll, squeeze, squeeze, mass. And record the change, or do that. Then record your percent change in mass. And do your calculations right underneath your data table, yes? And then you're going to do 3. Other teams are going to be doing 3. We're going to combine all that data, average it, plot it. Then I should be able to give you any solution. You should be able to tell me what molarity it is once we have that data. Does that make sense to you? Okay? Ask your bio buddy if you have any questions. That is one of your essay questions. Okay. Come back to me again. You ready? Okay. So now, when I say osmosis, this is just middle school understanding, right? High school is carrots and pickles. College level, AP, is mystery solutions. How do I figure it out? Do you see how we leveled up? If you don't even understand this, do you see how you have harder with high school and then when I ask you to jump to college level? So you've got to have your basics down. That can't be part of your issue. Basics got to be down. Okay, so through the phospholipid bilayer, what was the other thing that we could do? What? Yeah, okay, so we could use a protein, and we could break down proteins potentially active and what? Passive. Okay, when we use those. Okay, now they could both be channels or what? Carriers. What does passive active mean? Are we okay with that? Okay, so passively it could be chloride ion channels that we talked about. Remember we linked it to what disease? Cystic fibrosis. So we could put it in there. Carriers, we could talk about what? We could talk about the sodium potassium pump if we wanted to, and that would be one that required energy. Okay, so when we talk about proteins, they're channels or carriers, sure, but they would be under the heading of passive or active. If you use a protein passively, okay, passively, what is that called? Yes. Facilitated what? Diffusion. This all right here, this is straight up diffusion, right? Because you're going what? Through the phospholipid bilayer. Do you notice I'm trying to present it in a different way than the way I gave it to you in class, right? So you look at all the different parts and you kind of stitch the whole thing together. So this would be facilitated diffusion. This right here, if you do it with a protein, it's called a pump, like the sodium, potassium, ATPase pump, if you want to do the more modern way. Okay, we good? Can I keep going? Okay, then the next thing we would do is what? Yeah, so whole membrane. I was running out of room, so I need to shrink it down. Okay, here we go. Now, whole membrane, right? Then I have two categories. And by the way, whole membrane is always going to be what? Active, because you're using the whole membrane, okay? What are my two categories of whole membrane? Exocytosis and endocytosis. Now, endocytosis had how many? 3 types, okay? What were the 3 types of endocytosis? Phagocytosis, which is cell eating. What was the next one? Which was? And then what was the last one? Receptor mediated endocytosis. That's where you go ding, 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 ding. Okay, we good on that? All right. Let's see. Boom, boom, active transport. Okay, I think that's good. That is everything we've done so far. There's more that I'm going to relate to the lab that has to do with water potential, and I'll touch on plants and plasmodesmata and those. But I think that is good. Do you have any questions you want to ask me? Are you feeling smart? Well, very smart. Do I want you to make good choices this weekend? Okay. Do you know that I love you? Have you started working on your lab? You guys should have like lab parties and like sit around and order pizza. Once we get through the background, we can go have a piece of pizza. Okay, now we have to go through pre-lab 1. Now let's go get a piece of pizza. Yeah. It's a plan. Hook up. Not hook up, but so glad that's on the recording. Okay, make good choices. Don't forget to do your pre-lab. It's doing. Hey, clarification, because I had some weird questions at the end of class. Do you have to fill out all? Do you have to make all the tables and everything? Yes, all the way up through where I say what? Stop. Okay. So the only tables that will be filled in though are the one that when we did here with the starch and the iodine. Do you need me to go over that at all, or the analysis of that? Are you good?
I have a question.
Yes.
So if it's like a different shade of orange, does that matter? Or
No.
Okay.
It's not. That part will be filled in, and you should do your like what was the evidence that iodine moved? Because iodine definitely moved, right? Iodine moved from the beaker to the dialysis tubing, because the interior of the dialysis tubing turns blue, because when starch and iodine meet, that's what happens, right? So it doesn't need to be in complete sentences in that table. You just need to be able to support that you know it moved or didn't move. Okay, so make sure you have that all the way done. And don't forget to leave space after pre-lab number 2, because that's when you're going to need to calculate your percent change and then address claim, evidence, reason. Make sure you leave room for that. Okay, anything else? Yes?
For the background paragraph, when you said like skip spaces on like the thing, on like
Yeah.
the actual one, should we skip spaces like on the left and like too, like between each question?
I need more help.
For like, so for the background paragraph, now there's like different questions.
Yeah.
Should we skip like
One line between each one? Yeah, but then between sections like background, pre-lab, skip more than one line, otherwise it looks like a run-on sentence. Does that make sense to you?
Yeah.
Okay? I need to have more space between the sections than you have between the spaces of each statement of just the background. Otherwise it looks the same as that. Yes?
Wouldn't the background just be a cohesive paragraph?
Except that I said to skip a line between it. So I don't know how cohesive that will be. Yeah. What else? I did say that. Okay, I love you. Have a good weekend. Chairs up, chairs up. Can you all do the chairs? Chairs up.